Hey everybody, it's Mr. N, and in this lesson we're going to talk about some triangle proportionality theorems. And some of these will move over into other parallel line theorems. So let's take a look at the first one that we have here. And this one says, if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. So basically, if I have a triangle right here, such as this one, ABC, and I have a line inside of it, no matter where I put it, this DF line, as long as it's parallel to AC, to that base, so as long as these two lines are parallel, what's going to happen is I'm going to have proportional triangles all throughout here. Every triangle that you see, the big one and the small one, and every little segment pieces, they will be in some sort of proportion that relate to each other. Okay, so here's what I mean by that. We know that if I take this big triangle, which is ABC, and I take the smaller triangle right here, which is DBF, well, we know that these two triangles will be similar, okay? And you could do it multiple ways. You could do it angle, like this one, so this angle and this one, and then this to itself, or you could just do these other ones over here, right? And basically you'll end up with angle regardless. But because of that, here's what I can conclude. All these things that result as because of the similarities. So the first one is I can say, let me erase some of these things on here so that you could see it a little bit better. And the first one, I can say that AD, this piece right here, to DB, this piece right here, is similar, so equals CF, that one right there, to FB, that one right there. So that's the first proportionality. So this piece to that piece, the smaller piece down here to that piece right there. Okay, so that's the first one that I can say. But then there's so many more that I can conclude. So let me erase this first one and show you what the other ones are. So the other ones over here, I could say that DB right here to BA, the whole thing is BF, this small one, to BC, the whole thing. So I could say these two parts, let me use the pointer tool and show you. I could say this part to this part, this part to this part. I could say the whole thing to the top, the whole thing to the top, and guess what the third one I would say? I could say the whole thing AB to the bottom, over here AD, the whole thing BC to the bottom FC. So basically there's three sets of proportions you can set up, and those were the three. So now the converse, if any of these are in proportion, then these two lines right here would be parallel. So what happens with this is it holds true for all parallel sides. So parallel lines, I should say. So if I've got more than one parallel line like this, now I have all these parts over here on this side that are in proportion. So RS to XY, RT to XZ, RS to ST, XY to YZ. So all of these will be in proportion, just like in the triangle that I did above. So that's what happens when the lines are parallel. All these little parts, you can set up ratios and proportions to them. Just be consistent. So if I use this little piece, it'll be like this piece equals this piece over this piece equals, if I use the whole thing, equals the whole thing here over the whole thing there. All right, now we've got this next one. That's the triangle angle bisector theorem. So if a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the two sides. So if W or YW right here bisects angle Y, so angle 1 would be congruent to angle 2, then I can say X to W and then X to Y is equal to z to w, and z to y. So here's what the way I like to present this. I like to say, as long as this is an angle bisector right there, well then, I do it like this. I go from the y, I say this piece to that piece, this piece to that piece. So I just start from here, and I go boom, 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 boom. So that's the ratio I set up. So this piece would be yx, this piece would be xw equals, then I do it the other way, yz to zw. And as you can see, it's the same way that the book presents it. To me, it's just a little bit more organized. I just see it the same way. Basically, they're doing the same thing. They're saying, okay, this comes down here, cuts down, then you could say, boom, this piece to that piece, this piece to that piece. Regardless, it's these two ends to those two ends that are proportional. Okay, so let's take a look at some of the examples that we are going to go over. And I'm going to flip the page. And here are some examples. And on these, we are just going to find the value of x. So let me enlarge this just a little bit here so we can see a little bit better. And on this first one, I'm looking for what's parallel. And I've got this parallel to this. So then I can say this piece to this piece to that piece. Or I could say the whole things. But it's easier if I just say x to 33 equals 18 to 27, just like that. So I'll end up with 27x equals 33 times 18, and that comes out to be 594. So then divide each side by 27. I'll get x is 22. All right, moving on to the next one. These two are parallel, so I could say 12 to 9, and on this side 16 to x. Cross multiply, 12x equals 9 times the 16, which is 144. So x is going to be 12. All right, let's see what we got next. Over here, we're going to say, we know that these two are parallel. So now they're giving us a whole piece. Okay, so we know the whole piece 20 to this top piece x will be the whole piece 16 to the top piece 12. So 16x equals 20 times the 12, which will come out to be 240. And divide that by 16, you'll get x equals 15. Okay, now let's take a look at the next one. It's the same thing here. They give us a whole and a part. But since they're only giving me the x as this part, I'm just going to, on this, see what this little piece will end up being, which will be the 27 minus the 15, so that piece is 12. So it's easier if I set it up this way instead of saying the whole thing, because then I would have to say x plus 20. Sometimes you might have to do that, though. But for this one, I was able to solve that piece for 12. So I'll say this piece, x, to this bottom piece, 20, equals this little segment, 12, to that bottom segment, 15. So now let's cross multiply, and I will get 15x equals 20 times the 12 again, which is 240. So then dividing that out, 240 divided by the 15 gives me x is 16. All right, let's see what we got on the next problem. Over here, here's my three parallel lines. So that means these parts are my segments that will be proportional. So over here, 5 to 4 will be proportional to x minus 5 to 8. And so this piece to this piece, that to that. So now I can cross multiply, and I will get 4x minus 20 when I distribute it equals 8 times 5, which is 40. So adding 20 to each side would give me 4x equals 60, so x would be 15. All right, now take a look at this next one. They tell me here that this is an angle bisector. So that means I'm going to end up with proportional thing since this bisects the angle. Now, here's what I'm going to end up with. 24 to the x equals 18 to the 12. All right? So then we cross multiply, so 18x equals the 24 times the 12, which would come out to be 288. And divide that by 18, and I'll get x equals 16. On the next one, it's very similar, so let's take a look at what we got. Over here, I can say this is the angle bisector, because they told me that these two are congruent. So x to 8 equals 12.5, boom, to the 10. And now cross multiply, 10x equals 12.5 times 8 is going to come out to be 100. So x is 10. And that's it. Those were all the examples I wanted to do for you. So hopefully those weren't too hard. All right, thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.